Welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. There is one more kind of new topic that we want to look at under the heading of functions. And this is something called a function literal. So you should remember from in chapter 3, we talked about literals as being kind of the simplest, most straightforward things that have a value to them. So for example, 5 is an integer literal, and 7.23 is a double literal. When you put something in double quotes, you get a string literal. When you put a single character in inside of single quotes, you get a char literal. There is also literals for true and false, the Boolean values. Okay, so the term literal just means that you are able to type in and directly create an object with a particular value. The fact that Scala has support for the functional programming style really means that it's beneficial to be able to type in functions using a short syntax, and so we refer to this as function literals. Now we've seen how we can use def to create a function that has a name. Doing something like that. Okay. The literal this is creating a named function, not using a function literal. There are two syntaxes for creating function literals. The first of which, and kind of the normal one, uses a symbol that we read as rocket. It's an arrow that points to the right that's made out of an equal sign and a greater than. And the syntax for these function literals is that you have an argument list. So let's say x is a double, and then a rocket, and then what you're doing with x. And so this gives us back a result which is of type double double, and it's equal to a function. And I gave it the name res5. And you would expect if we have a function called res5, we should be able to pass it a value, and it gives us back something. And that works just the way you would expect it to. Now, you could also give this a name. How about I call it f2? By using a val and creating a normal variable that refers to this function literal, which has the type double double. So this is this is your basic syntax for a function literal that has just one argument. We could also have a function that takes two arguments. Okay, and we could call it in the way that you would expect here. Turns out that most of the times when you use function literals, you will wind up being able to leave off these types here. Now I can't in this usage because it turns out that this usage right here is not the standard one. We will see function literals a lot more we'll see them some in the next chapter, and then a lot more in the chapter after that. And in general, you will not have to provide the types to Scala, because it will be able to figure them out. In addition, when we get to that point, we can introduce the shorter syntax for function literals as well. Now, why do you need function literals? After all, we can define these functions like this just fine. The idea of function literals really becomes significant when you want to use what are called higher order functions. Now, a higher order function is a function that either takes functions as arguments or returns functions. So it's a function that plays with functions, which is why it's referred to as a higher order function. The simplest higher order function that you might be able to think of is a composition. So if we had two functions f and g, which both take one argument, so let's say we'll come back up here and we will just rename f to be x squared, and we can create g as x plus 5. Okay. So f of 3 is 9, and g of 3 is 8. And you can do function composition. So f of g of 3 is 8, and then pass to the square function, which gives you back 64. Okay, so this is a standard notion. It's called composition. And we could define our own compose. Turns out there actually is one built in. You can do f dot compose g, and let's say that h equals that. And then if I do h of 3, it's the 64 that we had before. But I want to write my own function for doing compose. So I want to write compose, and it needs to take two arguments. Actually, I'll just call them f and g. Now, this is where things get interesting. I need to specify the type of this function f. And the REPL has been telling us something about this right here. You can specify a function type by using the rocket. So, and you can put parentheses around here. Turns out for even for the declarations, if you don't need the colon and you only have a single argument, you can leave off the parentheses. Also for types, if you only have a single one, you can leave off the parentheses. If you had multiple arguments, you would have to include the parentheses. But we don't here. So f is I want one function that takes a double and returns a double. And then I want to have another function that takes a double and returns a double. And I want this to give me back a function that takes a double and returns a double. Okay. And what does this look like? Well, it turns out that it is as simple as doing, well, we could do f dot compose of g. Kind of, that feels like cheating though. How about we return a function of x is a double that is f of g of x. Okay? Because that's what we really want this to be. And so now we've defined compose, and it takes a function f and a function g, and it gives us back a function that goes from double to double. And now we can define another h as using our compose on f and g. And it gives us back this new h. And if we call it on 3, we get 64. Okay, so this compose here is an example of a higher order function because the things that we're passing in are functions, and it gives us back functions. Now, I have to admit, this is a topic that often causes students' brains to explode. When you start talking about higher order functions, you have to start thinking much more deeply, because this is something that you're not used to from math. The idea that f of x equals x squared, well, that was, or in Scala version, x times x, that is something that you are familiar with. And it's possible that you've seen composition in math classes before, but you really haven't talked that much, most likely, about having functions that take functions and give you back functions. That's just not something that is considered in the standard curriculum. It's kind of a higher level thing to think about, but it winds up being remarkably powerful. So wanted to introduce it here because we will be coming back and seeing these things again, and we will be using these higher order functions inside of the libraries of Scala to allow us to say very powerful things in a small number of characters. So that's it for this video. You should try building some of your own other higher order functions like this, and instead of doing composition, see what else you could do to possibly combine functions, or maybe you take one function and you alter it, so you make it so it's applied multiple times or whatever. You should play around with that and see what happens.